So, well, we've seen that we've got some indicators and we've got a nice, simple, straightforward trading strategy, which we've tested in a vectorized way. And of course, there's other ways to test trading strategies, specifically the event-based one. So let's look at the next indicator, which is called the Bollinger Bands. And it's also a very interesting one. And it's often used for mean reversion trading. So moving averages are often used for trend-based trading. And Bollinger Bands are in many cases used for mean reversion trading. Now, this is not always the case, but it's definitely one of the cases. And I want to show you how this works. So this is the next indicator. And of course, there are many different ways to combine indicators and to do different things with them. And of course, we cannot go through everything here, but let's just see, so you get a bit of inspiration to start with, what we can do with this type of indicator, like, for example, a Bollinger Band. And the first thing is to actually figure out how the Bollinger Band works. And so to start with, we can actually call the Bollinger Band, and in TA-Lib, it's called B-band. And let's test this first. So we go TA-Lib dot B-bands. There we go. So TA-Lib B-bands. So what you have here is basically, again, a real input. And then you've got several input values. You've got a time period, which is effectively your look back. And then you've got these two, NB dev up and NB dev down. And I will show you in a moment what these are. So here you've got the input parameters, the default values. So the time period is 5. And then you've got these two values here, 2.0. And then the outputs are upper band, middle band, and lower band. All right, so it's called Bollinger Bands. Now let's have a look what these actually mean. So in order to do this, the first thing we need to do is we run our function again, and we use prices. And what we do is first we use the default values. We don't have to plug them into Bollinger Bands. We can just run it. And then as you can see, you get 3 outputs here, which is effectively the upper band, the lower band, and the middle band. Now, when I just looked at this, I couldn't actually remember which one is which. So let's have another look again. TA-Lib.B-bands. So we've got the upper band, the middle band, and the lower band. Okay, great. And so what we can do is we can go call this up, mid, and low. And we've got our B-bands. And so one thing we can do now is we can plot this. So we do plt.plot, and we do again the last 500. So we do up minus 500. Yeah. And then we copy that. We do the middle band and the lower band and the prices. So we call this prices, up, mid, and low, and we plot it. All right, so you can see this is actually the bands, and what you can see is it's actually quite difficult to see what's going on here. So let's just plot the last 100. That makes it a little bit easier to see, I think. Okay, so actually this is also still a little bit hard to see. So what we can do is we can actually make our prices a little bit more, plot a thick line, and then the upper band, we're plotting a dashed line, and for the lower band we're also plotting a dashed line. All right, so this makes more sense, doesn't it? Okay, so can you already see, Josh, what's happening here?
It seems like our prices are moving within the upper and the lower bands.
Yes. So what are the upper and the lower band? Well, first of all, what we do with the middle band is what we've done before. We're actually calculating a simple moving average of the prices. And as you can see, that moving average again follows the price curve. And you can also see, and it's always a bit behind the price curve. That's what's called a lag. And the lag is a function of the look-back period. So the longer the look-back period, the more lag we have. Because, of course, the price looks back, and so it responds a bit more slowly to price changes. So the moving average has a lagged response to the prices. And then what we do is we calculate the standard deviation of our prices, of our price curve, and then we add the standard deviation to our moving average curve.